All right, now you know what surrounding is, what types of system is. Now let's talk about the types of process. Okay, there are two types of process. We have exothermic process, which is the process that gives off the heat to its surrounding. Right? Give you some example here. So let's say water is a system. So converting liquid water to an ice water. So you put liquid water into the freezer, right? So it will lose heat because the freezer is cold. So liquid water loses heat, become ice water. So we can write like this. So liquid water to ice water and plus energy. So energy is coming out. Or the combustion of hydrogen gas. If you still remember, the hydrogen gas is flammable, so you can burn it in the presence of oxygen to make water and produce large amount of heat. I'll show you some experiment right here. So we have a hydrogen balloon and helium balloon, right? So we burn, this is like a slow motion, so we burn a hydrogen balloon. So there's a torch right here, getting closer, and the reaction gets started, and the explosion. All right. Guess what? The helium balloon also come into contact with the fire, but the helium balloon does not explode. How come though? Well, helium, if you remember, helium is one of the inert gases. It doesn't do any reaction. So no reaction with helium. And helium just stay right there. All right. Next one. So endothermic process. So it's a process that absorbs energy from its surrounding. Okay. This one, for example, so converting liquid water to a gas to a vapor. So you have to heat it up. Right. So just like boiling water, or some type of chemical. So this one is ammonium nitrate. Once it dissolves with water, it will absorb some amount of heat and become ammonium ion nitrate. They just dissolving process. All right. And actually, this is true. I'll show you some experiment right here. So we have a solid ammonium nitrate. This is at room temperature, 22.5 degrees Celsius. All right. Now adding water, so the temperature is coming down, and the temperature stops at 3.5 degrees, just dissolving ammonium nitrate, right? So this whole process is an endothermic process. That's the reason why we use ammonium nitrate in an ice pack, right? You might have heard about ice pack before. So when you usually in sport, and you get injured on your body, so you put ice pack on it, so prevent the inflammation. Okay. Not only ammonium nitrate can be used in an ice pack. So we have ammonium nitrate, ammonium chloride, or urea. All right. Now, concept test real quick. So if you've been following me, considering an ice pack melts when you put an ice pack on an injured ankle, is this an endothermic process or exothermic process if your ankle is a system? Okay. So now your ankle is a system and you put ice pack on it, and ice pack melt. Well, when the ice pack melt, of course, the ice pack absorb the energy, right? So absorb the energy. But right now the system is your ankle. So your ankle loses energy, right? So loses energy, so the temperature drop. That's an exothermic process. All right, one more time. So endothermic or exothermic process. So ice melts to liquid, right? The system is water. So melts. When it melts, it's going to absorb energy from the surrounding, right? If you remember the solid, the same substance, the solid form has lower energy than the liquid form, and the liquid has lower energy than the gas, right? If you want to go from the solid to liquid, you have to add energy into it. So and the system is water, so this is absorb energy. Okay, so we write like that. This is an endothermic process. Next one, an acid and a base react, releasing heat. Releasing heat, of course, that's exothermic process. A log burns in a fireplace, right? The log burn. There we go. So I'll put the log in there. What happened? Well, the reaction keep going, right? And releases heat. That's why we feel hot, right? So if the log is a system, so the log has to release the energy. This is an exothermic process. Okay. All right. Pause the video right here. Try it on your own and then check with me. Write a chemical expression of the following changes, including the energy flow in or out. All right. So freezing water. So we have liquid water go to ice. Right. In this case, so the liquid water have to release the energy. So put this guy in the freezer. So release an energy. So liquid water to solid water and energy coming out. Okay. All right, next one. Ammonium chloride dissolves. It absorbs heat from the surrounding. So ammonium chloride dissolves, so solid to aqueous and absorb. Here, put energy right there with the reactant. All right, now we're gonna go back to the Aflac. So an Aflac duck. An Aflac duck in Japan looks like this, not an Aflac that we are used to. So they make it a little bit more for the audience with it Japanese. So in Japan, there's like a tradition. It's called this guy. This looks like a cat right here. There's a belief that if you have this like a cat with his hand come up right here, so it will help you bring the customer to your business. Could be a restaurant, could be any types of like grocery store, could be anything. So it's just believe. The cat in Japanese is what, neko. So like a neko right here. So we have a kind of hybrid between a neko and an Aflac duck. So, and in 2003, sometime between 2000 to 2010, when Aflac duck went abroad to Japan, so they got this commercial. Let's take a look. America family. So it's pretty cute. I got one more, but a little bit later. Okay, let's go to the next video.